Okay, once again, hello everyone. Just wanted to record a little video here, another supplemental, this time based on Booleans. So I want to talk a little bit about Boolean values and then also how we can create conditions using relational operators and Boolean or logical operators. And then also bringing back strings into the mix. We'll look at the compare to and equal methods on the string type so that we can see how we can use strings in our conditions as well. Once again, I've just got a very basic program here, lesson to Boolean. Again, I'm not going to create a full program. The purpose of this short video is just to do exactly what I mentioned, just explore the types, explore how we can create Boolean conditions with relational and Boolean operators, and then we'll go from there. So what I'm going to do to start things off is just declare a variable that's a Boolean so we can see what that looks like. And in C#, the Boolean type we'll be using is small b bool. And that's it. And then we could create, perhaps we have some kind of a flag that's either true or false. So we can create a variable just like any other variable, and we can assign it a value. Now, the two literal values for a Boolean type are true and false. Okay, and you'll notice that when I type those out, there's no quote, single, or double. Those are the literal values that are used in C#. So both true and false are reserved words. We can't use those on their own as variable names, but that's fine. And that's really it. A Boolean can either have a true or a false value, and no more, no less. And you might be thinking, well, why is that useful? And it can be useful because we can use Booleans now to make decisions and introduce branching statements into our programs. So up to this point, we've just created programs that are a simple sequence. They run from one step to the next in sequence until the program ends. But once we understand how to use Booleans, we can start asking questions and making decisions. If something is true, then we can execute a different branch of code. And so Booleans allow us to do not only the basic branching that we're going to see in the next couple of lessons, but also to repeat statements, which is quite useful. And they can be kind of hacked to do other nifty things that we're not going to look at. But for the most part, the big thing for us in the introduction of Boolean values is the introduction of branching statements. And so how we go about creating conditions that we can use to branch to produce these values is with relational operators. So a Boolean variable on its own isn't useful insofar as we can just have a value. But what is more useful is to determine whether a value is true or false, right? And then we could maybe save that into a variable and use it later. So the straightaway assignment like I have here isn't all that useful, but determining whether something is true or false is. So I'll just get rid of that for now, and I'm going to replace this with result. And so when it comes to creating conditions, usually what we're trying to do is make a comparison, right? Either two things are equal, one is greater than another, or greater than or equal, or less than, or just not equal. We try to ask those questions, and those operators that we use to create those expressions yield Boolean results. So working with numbers is the simplest way to introduce this concept. So if we were to look at whether something was less than something else, we could store that result in our result variable. So we could ask the question, is 4 less than 8, for example? Okay. Now on the right side of this assignment statement, I've got numbers and a relational operator. Okay. But when we use the relational operator on compatible types, the result is going to be a Boolean. And so that's why we don't see any errors here. The expression 4 less than 8 yields either a true or a false value. It doesn't yield an integer. So unlike what we learned in the previous lesson with arithmetic and numbers, where if you use ints in an expression, you get an int. If you use a double in an expression, you get a double. Here, if you're using a relational operator, you will get a Boolean result. And so just like we had done before, we can experiment with these expressions, and then we can just write out the result variable to see what the result of that expression is. We could, of course, place the expression directly in the right line method call, but we'll do it removed like this just so we can clearly see what's happening. So when I run this, I would expect to see that that's in fact true. And of course, that's what happens here. So is 4 less than 8, the result of that expression is true. If we were to flip that around and instead have the condition asking whether 4 was greater than 8, now I would expect the opposite to be true, that it's no longer true, it's false, right? And those are the only two results you're going to get from a relational operator. It's either the relationship is true or it's false, and that's it. And again here, there's no reason why you have to use literal values. If we had numbers, so let's declare a couple of ints. I'll declare int x and y, and let's assign those the values of 4 and 8. Okay, so we could do something like that. And then now we could use the x and the y variables here. Again, it doesn't matter whether you're using variables or literal values. What matters is the type. So if you have a variable, the type and the value of the variable is what's used in the expression. So that's very important to remember. I know a lot of times in my videos you might only see me use literal values, and that could be confusing. But I want you to remember that wherever I use a literal value, you can always put a variable of that type in its place. So this would yield the same result where x is 4 and y is 8. Well, is 4 greater than 8? No, that's false. So we would see the same result of false being written out to the console. Okay. And again, there are other operators that we can explore. Once you know how to look at one, you can look at the other. So we could ask the question, is x equal to y? Is 4 equal to 8? And again, on that, I would expect to be false. They don't match. They're not the same value. Well, we could ask the opposite, which we would expect to be true, which is x not equal to y? Okay, and the exclamation mark is used to signify not in C#. So we read this x not equal to y, and yeah, 4 is not equal to 8, so I would expect that to be true. So this is just a quick rundown of how to quickly build these relational expressions and see them in action. And again, as long as you have types that can be compared, that's totally fine. So in the previous supplemental video, we looked a little bit at chars, and we mentioned that chars themselves are numeric, kind of under the surface. So we can use chars in this way too. So we might have something like char, let's do it this way, response, kind of sticking with the lesson. And let's say the response is char capital Y. So we can do a comparison and ask, is the response equal to Y? And that works. We don't get any errors, right? I can ask whether the value here on the left is equal to the value on the right, because under the surface, as it were, these chars are treated as numeric types. So we can do direct comparisons. We can even do relational comparisons. So if we change response to, let's call it A, and so I'm saying, A is just representative of the char A. We can now do things like, okay, is A less than the character B, right? And if we were to check that lexicographically, we would expect that A comes before B, and therefore A is less than B. So this statement I would expect to be true. And so if we execute it, we can see that, yeah, it is true. A is in fact less than B. So we can make these relational comparisons on char types. We don't have to use special methods or anything fancy to work with those. Let me delete all these and clean it up a little bit. We can't do the same thing, however, with strings. So if we have a string A, for example, and we want to know whether or not, I'll keep the result here. And we want to know whether or not A is less than, oops, keyboard is sticky. It's complaining. It's not even trying to let me do what I want because the types are different. So if A is less than A, right, you'll see that we've got an error here, right? There's an exception. It's like, well, it's not going to work. And the operator less than cannot be applied to the operands of type string and string. It doesn't work with string abstract types. It doesn't know how to compare them. And that's because of the way that strings hide their internal representation. The string variable itself isn't its underlying value, right? It's more of a reference. And we haven't really talked about that in detail, but we'll talk more about that when we get into objects and classes later on in the course. But the direct comparison can't be made on the variable itself. If we want to compare the value of a string or an abstract type, we need to use some kind of a method that can take in a value and then do the internal comparison kind of on the guts of the type on its own. And so this is where we would need to do something like call a compare to. So we could say, for example, does the variable string A, or let's do it this way. Let's update this a little bit. ABC, we'll make it a bit longer. So we could ask, is ABC, and then call the equals method, does that string, does the internal representation of ABC, the variable, match this particular string, ABC? And so that's fine, okay? So if we want to do comparisons with strings, we have to do it through the methods that are exposed on strings themselves. We can't do it with comparison operators, okay? So here, is the string ABC, does that value equal this value? I would expect the result to be true. They are the same 3 characters, and we can see that that's true. If we switch it up a little bit, again, because case matters, right? Is lowercase ABC equal to capitalized ABC? I would expect the result to be no, it's not, okay? Now, sometimes you'll want to make that kind of a comparison, a case-insensitive comparison. And there are a couple of ways to do that, but the most kind of brute force way to do it would be to ensure that both values that you're comparing are in the same case, okay? And this is where the 2 lower and 2 upper methods can be used. So if we want to make a comparison to a literal uppercase value, let's say that this ABC was entered by the user, and we didn't know whether or not they entered a value in capitals or lowercase letters. Before we ask whether or not this string value equals this capitalized ABC, we could first call the ABC.toUpper method, and toUpper will return a new string that is the capitalized or uppercase version of this string. So first we take lowercase ABC, we uppercase that string, and then we take the uppercase string and we ask if it is equal to the capitalized ABC. And so I would expect this to be true. And this chaining of methods, one after the other, here I've got 2 methods chained together, is fine. Again, so long as we understand what the type is that's returned from those methods, we can do things like this. Okay, so that's true. So small ABC, if we first uppercase it and then ask if it's equal to the capitalized ABC, is true. Okay, if you don't feel comfortable chaining methods together like this and you wanted to create like an intermediate variable like capital ABC and assign that value first, that's totally fine. But this is also valid and an easy way to manipulate values to get what we're interested in so that we can make comparisons like what we see here. And so that's a little bit of, again, about how to use these string methods to get Boolean results. The compare to method is basically the fill-in for the less than, equals, and greater than options, where we get a value returned. It doesn't return a Boolean, it returns a number, but we can then make a comparison on that number. So I'll just briefly show you how to use the compare to methods as well. So let's ask the question whether or not our ABC, if we were to compare that to a string that is equal, right? You'll see here that now I've got a problem because ABC compared to ABC doesn't return a Boolean. Okay, it returns a number. It's going to return either a positive, a zero, or a negative. And so we can't store int values in Boolean variables. They can only have values of true and false. So before we finish this, let me just comment this line out. And let's just see what the result of calling this method on multiple values is going to look like. So if we do a write line of the ABC compared to ABC, because those are equal, we're going to get a 0 output here. Okay, and then that tells us that there's no different. The string that we're comparing doesn't come after or before the string that we compared it to. It's equal, and that's what the 0 represents. Now, if we change this so that we compare ABC to XYZ, right? XYZ lexicographically comes after ABC. So ABC in comparison to XYZ comes before. And so when we run this again, we'll see a different output, which is a -1. And that is because when we compare this to XYZ, ABC -1 comes before. It is less than this particular value. Okay. And if we were to reverse these, if we had XYZ compared to ABC, we would get a +1, which tells us that XYZ comes after ABC. Okay, so those values on their own are not all that useful, but we can use them to do comparisons. So going back to our result assignment, we can't assign the integer value, but we can make a comparison, and we can say, hey, if I wanted to check equality, I could check if ABC compared to ABC equals 0. Now this is going to yield either a true or false. It will be true that this gives a 0, or it will be false. And the true-false value can be stored here. So this is kind of a workaround for the equals case. So previously we had abc.equals ABC, and we assigned that directly to result. Well, we could use compare to do the same thing, but we've got to add this piece on the end. So if ABC compared to the string ABC equals 0, I know that they are equal. That's true. Okay. If I wanted to know whether or not this was less than, so if we go back to this idea, so if we were comparing ABC to XYZ, I would then want to ask the question or the condition, does when we call compare to on ABC and pass in XYZ, is it less than 0? If that's true, then ABC, the value, is less than XYZ. Does that make sense? So we can still do relational comparisons, but we've got to mess around with it a little bit to get there. Okay. And so again, I recommend a little bit of practice. So set up some scenarios and try to guess to your best ability what the value will be, and then run through it in the code to actually see the result. And that's the best way to learn how these methods work, and again, how to build your skill in the programming language so that should the need arise where you have to do string comparisons, you have a pretty good idea of how to go about doing it. Okay, and now the final thing that I want to look at here with you has to do with the Boolean or the logical operators. Okay, so we'll stick with this result variable for now. Many times you'll be faced with a problem that has more than one condition that needs to be met. Okay, so we could look at something where maybe we're writing a piece of software that's designed to determine whether or not someone gets some government funding. Okay, and maybe one of the requirements to receive the funding is that they're under a certain age and they are a student. Okay, so in what I've just said, I've identified two conditions, right? So their age needs to be less than a certain value, and it needs to be true that they're a student. And so that's kind of the key. If you ever find yourself reading or even just speaking in that fashion where you're saying conditions and you're using words like and or not, then those are Boolean or logical operators, and we can use those to combine multiple conditions together to create more complex Boolean expressions. So in the case of checking whether or not an age was less than a certain threshold, and that perhaps a flag or a label for a student was true, we could do something like the following. So let's just define some variables so it makes a little bit more sense. Let's say we had a person's age, and they had to be under 25, so whatever, we'll say 18. And let's say we have a char for, I'm just trying to think of how I want to do this. Let's say we have a char to represent someone's current status, whether they're a student or unemployed or something like that. So we'll say we have codes maybe for that. So they have char status and they're a student, so that's char code S. So we could frame our expression here that someone has to be under 25 and a student, something like the following. So we would ask, is it true that the age is less than 25? And, which is the two ampersands together, that represents the and operator in C#. The status is equal to the char S. Okay, and so now you'll see all the errors go away, and what we've done is we've taken two expressions and we've combined them through this and, or this logical and operator. So in order for the result to be true, both what's on the left and what's on the right need to evaluate to true. Okay. Now, if only one of those things needed to be true, let's say the funding model for free dollars was that the person applying was either under 25 or they were a student. This is where we would use the or operator. And this is just two pipe symbols. If you don't know where to find the pipe symbol on your keyboard, it's on the backslash key, which is usually just above your enter key. So shift backslash will give you these pipe characters, okay? And that represents the or operator. So I haven't changed anything but the logical operation that joins these two expressions. And so in the previous one where we're saying it's this and something, both the left and the right need to be true to yield a true. Okay, I've included a truth table in the lesson for this topic. So refer to that and if you're unsure of when you would get an expected result. But if we were saying either side, either the left or the right side can be true, we would use the or operator. Okay, and so if we bumped up the age to, let's say, 38, well, this is no longer true. 38 is not less than 25. But the status is still equal to S. So it's this or this. And because this is true, we would still see a true result. Okay, so if we run it like that, I would expect to see true, and there it is. Okay, now if we go back and revert that to the and operator, now because this is no longer true, and I need this and this is going to yield a false. Right, and so there's our false output. So the logical or the Boolean operators, they require Boolean values in order to work. Okay, so we can't use something like 25 and 7. That doesn't make any sense. Okay, so the relational operators can work with numeric types, and the Boolean or the logical operators, they can only work with Boolean values. And you can chain these together to create any complex condition string or condition statement that you need. But just be aware that the more logical and relational operators you string together to make a very complex expression, the more difficult it is to evaluate. So you might want to bring in things like parentheses just to be explicit and clear about what it is you're actually trying to do. So, the expression worked fine without the inclusion of these parentheses, but including them like this makes it clear that, oh, okay, this is one term, this is another term. I'm going to evaluate these, and then we're going to do the and operation, okay? The logical operators have a lower precedence than the relational operators. And so that's why, even without the parentheses, this expression was evaluated first, and then this part of the expression was evaluated, and then lastly, the and or the or operators got evaluated. So keep that in mind when you're creating these expressions. You don't often need the parentheses, but a lot of the times it can make it clear what it is you're trying to do and easier to read for anyone that happens upon your code. Okay, so that's just a little bit more detail into Booleans, the relational operators and the logical operators, and a little bit about how to work with strings when we're trying to create our conditions. In the next lecture videos, we're going to put these conditions to use in our decision statements. So I'll see you there.